So now let's move on to interpreting the results of bone conduction and interpreting the results of air conduction and bone conduction when taken together. So with bone conduction thresholds are always going to be roughly equal to or better than air conduction results. And it is physiologically impossible for this not to be true. And I'll show you why in a moment. Bone conduction results are used to define type of hearing loss, and we'll come back to that as well. If we go back to the auditory pathways, you have the air conduction mechanism, which is sound traveling through the ear canal, the middle ear, and then the cochlea, and from there to the higher brain centers. With bone conduction, you're actually skipping the middle ear, the outer ear, and the middle ear space, and sending the sound directly to the cochlea, and then up to the brain. Now, you can imagine that if you had let's say you had a big chunk of earwax in the middle ear, the outer ear canal right here. You can imagine this may cause a hearing loss via air conduction. So you would see air conduction thresholds would be poorer or lower on the audiogram, higher in number. But you would expect in that same circumstance bone conduction thresholds to be just fine. Likewise, if you had a middle ear problem, the same thing. You would expect that interruption, that loss of energy transmission, to affect air conduction thresholds, but not bone conduction thresholds because they bypass the middle ear and outer ear completely. If you did have a problem affecting the bone conduction pathway, it is likely to be in the cochlea or in the auditory nerve, and both of those are also parts of the air conduction pathway. There is no part of the bone conduction pathway that is not also measured with air conduction. So, you can't have a loss of energy, a problem, a disorder, a dysfunction that affects bone conduction that does not also affect air conduction. This is why bone conduction thresholds are always going to be roughly equal to or better than air conduction. They can't be worse because there's nothing that affects bone conduction that would not also cause hearing loss via air conduction. So now let's talk about type of hearing loss. There are three main types of hearing loss. Conductive hearing loss is a problem in the outer or middle ear. It may be temporary, it may be treatable. Something like a cerumen blockage in the ear canal, or a middle ear infection, or a hole in the eardrum. These are all things that make energy transmission through the ear less efficient, but may be temporary, may be treatable. Sensory neural hearing loss is a problem in the inner ear or cochlea or the auditory nerve. Sometimes central auditory nervous system, but that's usually called something else. And then you have mixed hearing loss, which is a conductive hearing loss and a sensory neural hearing loss together in the same ear at the same time. So now let's link type of loss to the audiogram. What you have to do is compare the air conduction and bone conduction thresholds and look at the difference between them at each frequency. That difference is called the air-bone gap, if it exists. If air conduction thresholds are 10 dB or less from bone conduction thresholds, there is no air-bone gap and no conductive hearing loss. If air conduction thresholds are 11 dB or more from the bone conduction thresholds, and bear in mind, this means bone conduction is better by 11 dB or more, then you have an air-bone gap and you have conductive hearing loss. Anytime there is an air-bone gap, there is conductive hearing loss. There may also be sensory neural hearing loss, but there is always conductive hearing loss whenever there is an air-bone gap. So, we know Using the air conduction thresholds, you're going to describe degree and configuration. And then you're going to go to the combination of bone conduction and air conduction thresholds to see if an air-bone gap exists. If an air-bone gap is present, there is a conductive problem. Even if hearing is within normal limits, if there is an air-bone gap, there's still a conductive problem. If there is no air-bone gap, but hearing is not within normal limits, you have a sensorineural hearing loss. If there is an air-bone gap and bone conduction thresholds are not within normal limits, it is mixed hearing loss. And we'll talk about this more in class. So let's look at some samples. So an example of describing a hearing loss completely might be Mr. Jones has a moderate to severe sensorineural hearing loss in his left ear and a mild conductive hearing loss in his right ear. Or Mrs. Smith has a mild to moderate conductive hearing loss bilaterally. Mr. Snow has hearing within normal limits. Alright, let's look at this audiogram. If we look at the right ear first, just air conduction thresholds. These air conduction thresholds are within normal limits. If you add bone conduction thresholds, they line up quite nicely with the air conduction thresholds. No air-bone gap is present. Hearing's within normal limits for the right ear. If you look at the left ear, the same is also true. Right ear, hearing's within normal limits. Left ear, hearing's within normal limits. In this case, both the air conduction pathway and bone conduction pathway are functioning fully. Okay, so now if we look at the right ear, we see we have a fairly flat, mild to moderate or mainly moderate hearing loss here. And now if we add bone conduction in for the right ear, you can see there is a large air-bone gap. The difference between these two is 40-45 dB, and it's very large across the board. This is a large air-bone gap, and that means there's conductive hearing loss in the right ear. Additionally, if you look at the bone conduction thresholds, all the bone conduction thresholds are within normal limits, assuming this is, an adult. So bone conduction thresholds are within normal limits. That's the first question you want to ask. First, are bone conduction thresholds in normal limits? If they are, then you know there's no sensorineural hearing loss. Is there an air-bone gap? If there is, you know there's conductive hearing loss. So here, we have normal bone conduction, but a hearing loss via air conduction, and that means a conductive hearing loss. Left ear, still within normal limits. So, left ear is within normal limits, no air-bone gap. Right ear has a conductive hearing loss. So, something in the outer middle ear is causing a blockage, a reduction of sound energy, but only in the air conduction pathway. The bone conduction pathway is still completely intact. There's no hearing loss in that pathway. So now we've got the same hearing loss in the right ear, but now it's symmetric. So now we have bilateral conductive hearing loss. Now, we go back to the questions. First, is bone conduction within normal limits? No, it is not. And there's no air-bone gap. So you have the same hearing loss, essentially, via both air conduction and bone conduction, and that means the problem must be cochlear or auditory nerve-based, which makes it sensorineural. And normal left ear. So, sensorineural hearing loss in the right ear, hearing normal in the left ear. So in this case, the problem is in the cochlea, and it's affecting both air conduction and bone conduction and causing hearing loss. Now, likewise, we have the same hearing loss in the right ear, a different hearing loss in the left ear, but still you can see bone conduction thresholds in the left ear not within normal limits, but bone conduction and air conduction are roughly equal. There's a hearing loss in both pathways, which again means sensory neural hearing loss. Okay, for this audiogram, first, is bone conduction within normal limits? No. So we know there's sensory neural hearing loss. Is there air conduction and bone conduction? Is there an air-bone gap? Yes, there is an air-bone gap here. And so this is a mixed hearing loss. There is a sensory neural hearing loss, and there is also conductive hearing loss at the same time in the same ear. So, there's a hearing loss by bone conduction, there is a much worse hearing loss via air conduction. And if you look at the left ear, you can see sensory neural hearing loss, where there's hearing loss in both bone conduction and air conduction, but the hearing loss is the same. This is a great example. This is exactly what an audiogram might look like if you saw somebody with permanent sensory neural hearing loss who gets a cerumen blockage in their right ear, or someone with permanent sensory neural hearing loss that gets a middle ear infection or an outer ear infection in their right ear. They have this conductive component that when it's treated, if the cerumen's removed, if the ear infection goes away, these right ear thresholds are going to probably go back up. The conductive hearing loss is going to disappear, and the thresholds will go back up and be part of this group very close to the bone conduction thresholds. So you can see in this case, you've got two pathologies. You've got a sensory neural pathology affecting both bone conduction and air conduction, and then you have an extra pathology causing more energy loss via air conduction.